Hey class, in today's lesson we're going to talk about graphing radical functions, which is found in section 6-8 of your book. We are going to graph square root and other radical functions. So here we're talking about families of radical functions, specifically square root and other radical functions. They will look the exact same. So the parent function is y equals the square root of x. So by the way, what that graph looks like is just a simple graph like that from the origin. When you reflect it, you just make the a negative. Okay, to stretch, it has to be greater than 1. To stretch, or to shrink, a has to be a fraction or a decimal between 0 and 1. And then to translate horizontally is h, but it's opposite of the way you think, and k is vertical, and it's exactly the way you think. All right, so to translate a square root function vertically, okay, these are strictly going to be sketches. So I'm going to put that out there that this is just a sketch. It says, what are the graphs of the functions below? So if it's minus 2 and it's vertically, this means it's going to go down 2. So when I graph this, 1, 2, it's going to go from here and out, and that's it. This one is up 1. So up 1, and it's that way. Very simple. Let's do the try. Again, this is plus 2, so this is up 2. So up 2, graph. This one is down 3. So 1, 2, 3. There you go. We could make these more accurate using ordered pairs and a table, but we don't need to for these basic ones. All right, so now we're going to translate horizontally. So remember, these are opposite of what you think. So if I see plus 4, it's not going right 4, but it's going left 4. So here we go, 1, 2, 3, 4. It's going to go that way. This one, it looks like it should be left 1, but it's really right 1. So we're going to go right 1, and there you go. Okay, again, this one is going to be right 3. So 1, 2, 3. There you go. This one is going to be left 2. And there you go. In example 3, now we're going to start combining them. And this is where we should actually start adding in the tables. So the minus 3 is actually going to move it right 3. Right 3. And then the plus 1 is going to move it up 1. Now that just gives us an idea to know where the point of our function will be. So if I have moved right 3 and up 1, I know that I should choose x values that surround this 3. Okay, so when I choose my table, I should use values, and in fact I know it's negative, so I know it's going to go down, right? So I'm only going to choose values greater than 3. So 3, 4, 5, 6, and 7 should be good enough. So if I substitute in 3, square root of 3 minus 3, right? 3 minus 3. That's really negative 1/2 times 0 plus 1. That's going to go away, so I'm left with 1. Okay? Then, I'm going to erase this and try 4. Okay, if I put in 4, 4 minus 3 is 1. That's going to be negative 1/2 when I multiply it times 1. And negative 1/2 plus 1 is going to be 1/2. Okay, let's try 5. 5 minus 3 is 2. 2 times negative 1/2. Those 2's will cancel, so I'm left with negative 1. And I still need to add 1, so that one's going to be 0. 2 more. 6 minus 3 is 3. The square root of 3, we'll just leave that. That one is not a nice one to do. So actually I'm just going to kind of skip that one. It's really going to be negative square root of 3 over 2 plus 1. And if you want to throw that into your calculator, let's see. Let's see, this negative square root of 3 divided by 2 plus 1 is about, I'm going to say it's about 0.13. So very small. And then the last one, seven minus 3 is 4. The square root of 4 is 2. So this is negative 1/2 times 2. Those are going to go away. And then negative 1 plus 1, again, that is 0. It's feeling a little off. If I find my error, I'll state it. Okay, so 1, 2, 3, 4, 5, 6, 7. So 3 is 1. Okay, 4 is 1/2, so it's a little lower. 5 is 0. 6 should be below that. So let me just go ahead and type this into the calculator. I'm actually going to throw 6 and 7 into the calculator. So that'd be negative 1/2 times the square root of 6 minus 3 and then plus 1. Nope, I was right. It's about 0.13. And then for, if I put in 7, that's negative 1/2 times the square root of 7 minus 3 and then plus 1. And again, that one is 0. So that one kind of just really just kind of stays along here really. And we are done. Alright, and by the way, I found my error. It's not 0 right here. It's 0.29, which is about a third. So where I have 5, 1, 2, 3, 4, 5, it should really be up here. Actually, not even that high, a little lower. Either way, it's going to kind of go right in here. Alright, let's try, or try 3. Alright, so it says, what is the graph of the function below? So again, you just need to know how it shifted to know which values to choose. Okay, so plus 2 is really left 2 and down 4. So left 2, down 4, left 2, down 4 is about here. And we know it's going to go this way. We just need to know how, okay? So we should only choose values greater than negative 2. So when we choose, we're just going to pick 5 of them. Let's do negative 2, negative 1, 0, 1, 2. So if I substitute in negative 2, that would be 0. 0 times 3 is 3. That's going to be negative 4 for the first one. If I put in negative 1, that's negative 1 plus 2 is 1. Square root of 1 is 1. 1 times 3 is 3. Minus 4 is negative 1. If I put in 0, that's where we're going to start getting some decimals. So let's see. 3 times the square root of 2 and then minus 4 would give you about 0.24. Not fun. The next one is also going to give us a decimal. So 3 times the square root of 3 and then minus 4 is about 1.2. Okay, 2 would be pretty simple. 2 plus 2 is 4. Square root of 4 is 2. 2 times 3 is 6. 6 minus 4 is 2. So when we graph this one isn't even really that big. Negative 2, negative 4 is down here. Negative 1 is here. 0.24 is about here. Not even that high, really. 1 and 1.2 is about here, and then 2 is here. So this graph is going to do like that. This is a lot better graph than the last one, by the way, so sorry about that. Okay, let's keep going. All right, in example 4, this is going to be a pure calculator question. It says you can model the population P of Corpus Christi, Texas, between the years 1970 and 2005 by the radical function below where X is the year. Using this model, in what year was the population of Corpus Christi 250,000? P of X is going to be 250,000. So literally all we're doing is substituting. Now if I'm substituting this as 250,000 and I want to type this into my calculator, that means I need to subtract 250,000 on both sides. So what you type into your calculator as y1 is going to be 75,000 cube root of x minus 1950 minus 250,000. Specifically, what that looks like in your calculator is 75,000 minus you need to use the math button and go down to the fourth one. And it's going to look like a cube root symbol. Press enter and then type in x minus 1980. Press the over button so that you're not still under the radical, and then subtract 250,000. Okay, then you need to fix your window. Your x values is your domain, and those values should be from 0 to 2005, right? Because that's based on the year 2005. Y is your range, and that should be based on the amount of people. And I needed to be able to see below the graph, so I went from negative 100,000 up to 250,000. And that gives you just enough to where when you graph and you do second trace, go to 0, do left bound, right bound, and you will get that x that year should be, and I just had it, it's going to be 1987 is the year that had a population of 250,000. All right. And that's it. Let's go ahead and do the try for that one. So it says, in what year was the population of Corpus Christi? 275,000. So again, you do the exact same thing. So again, in your calculator, your Y1 is going to be 75,000 minus the cube root of x minus 1950 minus 275,000. And that shouldn't be a minus right here. Sorry. Okay, when you type that in, you may need to change your Y max, which I did. Either way, if you try this one, your year will be 1999. All right, we got one more. All right, so it says, what is the graph of the function below? Now we're talking about cube root. Now, by the way, cube root as a basic graph, as a basic parent function, looks like that, right? Because cubed look like that. Okay, so this is, for example, x cubed, and this would be the cube root of x. Okay, so again, just like how we were doing the other ones, you will shift accordingly. So the plus 1 is really left 1 and down 4. So if I go left 1 and down 4, it's going to be about here. So we need to choose x values that are on this one, because you notice that they go on both sides, we should choose 2 on the left and 2 on the right of the value surrounding, which is -1. So as my x and my y, I'm going to choose -3, -2, -1, 0, 1. If I substitute in -3, it's not going to be a nice one. Here we go. That would be the cube root of -3 plus 1 is -2, and then -4 is about -5.26. Okay, if I substitute in -2, that would be the cube root of -2 plus 1, which is -1, and then -4. Oops. Oh my goodness. Which would be -5, exactly. The cube root of 0 essentially is just 0, and then -4 will be -4. If I substitute in 0, the cube root of 1 is 1, and then 1 minus 4 is -3. And then this one isn't all that great. The cube root of 2, and then -4 is going to be about -2.74. All right, so when we graph, -3 And then negative 5.26 is about somewhere down here. Negative 2 is negative 5, so that's right here. Negative 2 is negative 4. 0 is negative 3. And 1 is negative 2.74, so that's about here. Alright, so that one did not do what I wanted it to do. Actually, I take that back. It did, it's just I needed a few more points, but essentially this is the center, right? So this would have just eventually started to do that, and this one would have started to do this to make the S. It still looks like a very bad graph. So really, if I really wanted to make this a lot better, I should have chosen 2 and negative 4. So if I put in negative 4, that'd be the cube root of negative 3, and then minus 4, which would give you about negative 5.44. So that kind of solidifies even better what we were mentioning. So it's about here. And then if I put in 2, the cube root of 3, and then minus 4 would give you about negative 2.56, which again, if I put in 2 and then negative 2.56, that'd be about here. So it should have actually started to come a little lower like that. All right, let's do the try. All right, the last one. Again, this minus 2 is about the only shift that we kind of get to see, and that minus 2 is showing us that it's going to move right 2. So if it moves right 2 and we're trying to use values that surround it, let's go ahead and just pick 3 values that surround each side. So if 2 is in the middle, I need to pick 1, 0, and negative 1, and then on the other side of that, if I'm using this as my center, I need to use 3, 4, and 5. All right, so here we go. Negative 1 minus 2 would be negative 3. Then we need to find the cube root of, the cube root of negative 3. And then multiply that times negative 0.5. And then add that to 3. And you should get about 3.72. I'm making that a little more difficult than I need to. Honestly, you can just type this into the calculator. So you would type it like this: 3 minus 0.5 cube root of 0 minus 2 is negative 2. And this one is about 3.63. If I put in 1, that's 3 minus 0.5 times the cube root of 1 minus 2, which is going to be negative 1. And that one's going to be 3.5 exactly. If I put in 2, that's 3 minus 0.5 cube root of 2 minus 2, which is 0. And again, that one is exact, and it's going to give you 3. 3 minus 0.5 times the cube root of, if I put in 3, 3 minus 2 is 1. That one's going to give you exactly 2.5. And it looks like the other two are going to be decimals. So again, 3 minus 0.5 times the cube root of 4 minus 2 is 2. You'll get about 2.37, and we have one more. 3 minus 0.5 times the cube root of 5 minus 2 is 3. And that one's going to give you about 2.28. So then you just go on the graph. Alright, so let's graph in a different color. Negative 1 and 3.72. It's kind of closer up here. 0 and 3.63 is a little higher than a half, so about there. 1 and 3.5 exactly is here. 2 2 is 3. It's a really bad graph. 3 is 2.5. 4 is 2.37. And 5 is 2.28. So again, this is really our center. And it's just kind of going like this. And we are done. Again, really bad graphs, but essentially, here's the deal. My main thing that I want you to understand is the transformations and how they affect the graph and how to produce your table. And lastly, being sure that you can throw this into a calculator to verify that your graph would be right. Guys, if you have any questions, please be sure to come see me for tutoring.